So welcome to the Understanding AI webinar. What I'm going to try and do here is give an overview of what you really need to understand about AI. So I can help you reason about how you can use it in your business, in your job, and be a part of the conversation. So hopefully give you the vocabulary and jargon that you're hearing all over the place so that you can put it to your own use. So here's what we're going to go through. I'm going to try and give you all of this in less than 30 minutes. So quick introduction. Secondly, what actually is AI? Thirdly, I'm going to go through the essential AI glossary, all the terms you need to know, all the words you keep hearing so that you can be a part of that conversation. Then I'll go through how does this stuff actually work under the hood? What's happening behind the scenes of ChatGPT and other examples? Then I will look at how can you determine what's hype and what's real, and not get caught up in all of the media stuff about Terminator, killer robots, and all this kind of thing, but focus on what are the big trends and how is it actually going to affect the things that you do in your day-to-day life. Then I want to talk about 4 really common use cases of AI in business, just things that every business should be doing. Just before we wrap up, I want to go through 3 steps that you can take to prepare for the future. Just kind of words of advice that I've seen work across companies I've been working with, or in my experience, teaching lots of people about this stuff. And then finally, if you make it that far, I'm going to go through a special announcement. It's the first time I'm announcing this. So hold on for that. That's what we're going to go through. So firstly, who am I? I'm Harry Berg. I'm an AI educator. I previously started, scaled, and successfully exit my previous company. I've had over 2,000 students in all kind of different forms, from live in-person lectures across some of the top universities in the world, to teaching lots of people online, both in the form of my previous company and in the form of running live online workshops throughout COVID. And I've also taught a lot of people one-on-one and one-to-few in small kind of apprentice-style groups. And I've taught everything from the deep technical maths behind AI all the way to the high level of using kind of third-party systems that are useful for companies in the format of company workshops, which I've done. So I've really seen the whole spectrum. And I think I've got a lot of experience in trying to communicate this stuff. And that's what I try and kind of focus my expertise on. I want to be the best communicator so I can get these ideas across to you to help you be a part of building the future. So I kind of ran into it there, but most of what I do now is advise businesses on how to execute and develop AI strategy, and just generally try and teach as many people as possible to build the future and be a part of that using a technical skill set. And I claim that I'm going to be the future AI apocalypse survivor, because I think it's going to be an apocalypse of jobs and an apocalypse of businesses when your competitors really start catching up with how to use all of these AI tools that are out there to their advantage. So I want to try and kind of put you in the competitive seat here and give you tools to win that. So firstly, what actually is AI? Of course, I hope everybody knows it stands for artificial intelligence, but what does that mean? So the way I put it is there's a few different definitions, but this one I like as a starting point. So AI is the pursuit of making computer systems that can do more and more of what humans can do without being told the step-by-step instructions. You've got these 2 different things: building narrow AI systems like recommendation engines, which are just good at that one thing, recommending the next song, for example. Or you've got general AI systems which aim to be able to do lots of different tasks and be helpful in a number of different ways, like ChatGPT. Through history, we've really started with narrow AI systems and moved towards more and more general systems. And the long-term goal of AI is that we have really powerful general computers which can approach any task, much like a human can, right? That's what makes us so capable in this world, is that we can approach any kind of problem. Maybe we're not perfect at solving it, but we have that intelligence that allows us to tackle it. And that means that, we can be very flexible and we can accomplish a lot. We'd like to be able to delegate more of our work to computer systems, which is why we want to pursue the goal of developing generally intelligent AI, or artificial general intelligence, AGI. That's the holy grail of AI development. So hopefully that gives a good understanding of what actually is AI. What are we talking about here and how does it break down a little bit? Show some few examples as well. So both of those things get called AI, narrow AI and general AI. And maybe if you look around you, next time somebody's talking about it, and you can think, okay, is that a narrow use case where the AI developed there is only going to be able to do this one thing? Or is it something where it can help in many different situations? So over time, we want to make computers that can solve wider and wider sets of tasks. We want them to be really general until we can delegate any of our work to AI and be free to spend our time on the creative expertise, our areas of creative expertise, our areas of interest. To really get into the depths of things, I want to explain the essential AI glossary. I think these are some key terms, keep coming up. They're probably stuff you're hearing, maybe the stuff which it might be helpful to have a clear definition for. Artificial intelligence, AI, simple definition here you can use is building computer systems that learn how to complete tasks for themselves without being told exactly how. Machine learning, it's a term thrown around all the time, kind of synonymous to AI when it's used in conversation. People just use it the same as AI. But I think the best way to explain machine learning is it's an approach to AI. It's an approach where the computer systems learn to accomplish tasks by learning from data. They've got examples of the data, and that's what they learn to do the mapping between inputs and outputs for, rather than being given step-by-step instructions again. So learning from the data. And then you've got deep learning, which again is kind of one of those terms mixed in with AI and machine learning and often used synonymously. But really what this is an approach to machine learning, where the underlying AI that you're using is a neural network. Deep learning is an approach to machine learning, where you're using neural networks, which I'll explain in a second. And machine learning is an approach to AI. And machine learning is where you're having the system learn from examples of data. And AI in itself is just having computers that learn to do something in some way without being given those step-by-step instructions. So AI is really all about making predictions. It's about having some input, for example, the sensors, maybe the cameras from a vehicle, and predicting what should the acceleration and steering direction of that vehicle be if you're working on an autonomous vehicle use case. That would be the prediction problem. Take those inputs from the sensors around the car, predict how we should accelerate and how we should steer. Another example would be voice transcription here. So you start with a voice and audio file, a waveform, and you want to predict from that what was the text. Or another example would be, given an image of someone's face, which is just data, can you predict from that data whether or not this is the person this system should unlock for? To make those predictions, we use these things which we call a model. So the model is the thing that makes the prediction. It takes in an input, it processes it somehow, and it predicts an output. So it might take in this input image, the model makes a prediction to output that yes or no, this is or isn't that person. So models, really what they are is just mathematical functions. It's just some equation where it says output equals some function of these inputs. To tie those things together, this is the model, the green thing in the middle here. It's the part which performs that mapping between inputs to outputs, makes a prediction of outputs from the inputs. Another term in the glossary is model training. So what does that mean? People talk about training your AI all the time. What does that actually mean? It's the process of learning to make good predictions of outputs, giving some inputs. So what happens most of the time is you start off with a model, a function which is going to make a prediction from the inputs, and it really sucks to start with. It can't do anything. It's getting the predictions completely wrong. So what you do is this training process where typically you show lots of examples to the model and you adjust that equation. You kind of, turn the dials on it so that it computes a slightly different mapping, and do that bit by bit, step by step, until eventually you end up with something that has the right kind of predictions. So that's the process of training. It's about tweaking the model, changing the parameters of that mathematical function so that the output is a different output when a prediction is made. So that's the training process. Neural networks are really kind of the models which run the world. So like I said, a model is just some function. It takes in some inputs, it performs some function to predict an output. A neural network is just a complex kind of function. I have this diagram here, and on the left is where kind of input comes in. So these are all the different input features. A bunch of calculations happen, and eventually it spits out some outputs. So this is just kind of a more complicated mathematical function. Back in the early days, we were trying to model the world with really simple functions. And over time, we've learned to build more and more complex models. And neural networks seem to work really well. Why? That's for a different video, so I won't go into that here. But my definition of a neural network is the model that makes predictions in today's most advanced AI systems. But to be more specific, in a second, I'll show the exact type of neural network. But firstly, here's just a few diagrams of different neural networks, different ways you might see them drawn. If you see any of these three things, you're looking at a neural network. Over here, this fully connected network. Over here is a certain type of neural network I'll talk about in a second. And over here is kind of a drawing of another type of neural network for processing images, a convolutional neural network. So, to be more specific, what kind of neural networks power today's most advanced AI systems? It's the transformer. So this is a diagram of a transformer neural network. And we've got these transformers. They're really powerful models. They can make good predictions from inputs of whatever kind of text or whatever kind of data they're working with, typically text, and we're all aware of the ChatGPT example. But a lot of the time, we don't want to start from scratch. We want to get something off the shelf, which somebody else has taken the time, effort, and expertise to train for us, so we can get this really good model that works off the shelf. So there are lots of different pre-trained models which have already learned to tackle a problem, and they're ready for you to use to make new predictions. So you might have heard of a few of these pre-trained models. GPT, I'm sure you've all heard of that somewhere. Llama, Falcon, Qwen, they're all pre-trained models which do slightly different things. GPT is OpenAI's proprietary model, or at least the latest version is proprietary. Llama is Facebook's completely open source model. Falcon is another very large and competent open source model, and Qwen, again, another open source model focused on Chinese text and Mandarin. The T in transformer, it's the same T that appears in GPT. So GPT, as in ChatGPT, stands for Generative Pre-trained Transformer. So now we can get an understanding of how all these terms are fitting together, right? We've got this transformer. We know it's a type of neural network. We know that that's a model, which is just something that makes predictions from inputs. And it's pre-trained, according to this acronym here, GPT. So GPT is the name for the model which underlies ChatGPT. It's the engine behind taking your request and taking your prompt request and producing a response. And so we've got this pre-trained transformer. It's been trained on lots of data, lots of internet data, so it's already very competent and already has a good understanding of how text works and what it means. And it's got this G here for generative. And generative AI is a big term these days as well. And really all that means is AI systems that generate data which is very realistic. It looks like the natural distribution of data which appears. So GPT can produce very natural looking text. It can generate the same kind of data that it's very familiar with. Another term when it comes to the engineering side of things, less the kind of theoretical side of things, is API. So an API is this is a term which is thrown around all the time, and I find a lot of people don't do a good enough job of explaining what it is, so I'll try and do it here. But an API is a piece of software that you can send a request to, processes that request, and it sends you a response. These appear in all kind of examples. For example, there's the OpenAI API. What does that do? Well, it's OpenAI's computer running in the cloud. You, as a person, maybe using ChatGPT, or maybe as a developer, you can send a request to OpenAI's API and get a response back. The job of the API as this piece of software is to know how to process different kinds of requests. It knows that, okay, this request is asking me to complete the sentence, predict what text comes next, and so that's what I'm going to respond with. But APIs appear in all kind of places across the software engineering landscape. Basically every big company has an API. There's a YouTube API, which is just a computer running in the cloud that YouTube owns. You can send it a request to upload a video or to change your password or whatever. So when you're interacting with YouTube on the internet, what's happening behind the scenes is your computer's making a request to the YouTube API and sending back a response, which satisfies that request. Basically, any company you can think of has an API. Whenever you call an Uber, when you push that button on your phone, what happens is your phone sends a request to the Uber API, and that responds with, yes, I've booked your driver, it's going to be here soon. So every big company has an API, basically. So API stands for Application Programming Interface. API, application programming interface, sounds like a confusing term, but it's really simple when you think about it. Application programming interface, what is that? Well, it's some piece of software which allows you to interface with an application, such as Uber, using a programming language. That's what it is. So you can write some code which makes this request. So you've got programming, which makes a request to interface with some application, and that application is going to send you back a response. So that's what an API is. I think that's a useful takeaway here, is if you understand what this is. So if I missed anything from Glossary, comment on a post or DM me and I'll make a video about it explaining it. My goal is to respond within 24 hours as soon as somebody makes that post. So anything you're not sure what it is, questions you've got, things that you think should be in the glossary, let me know. We're going to move on. So how does AI work under the hood? I'm just going to go through this quickly, really, but to be clear, you can use AI without developing AI. So if you're a leader at a company, don't think that you need to invest in building this huge AI team so that you can capture some of the benefit that everybody's talking about. You can go about it in many other ways. I'll go through those here. So if you're curious about what is going on under the hood, this is the usual process. So if you want to build your own AI systems, it typically looks like this. You've got to have some data. You've got to use that data to train a model on that specific task. For example, maybe you have all of the requests from your users from your customer support, and you want to train a model to respond to those requests. So you've got a data set of questions and answers from your customer support team. So you got that data, and you're going to train a model. Maybe you take language model like GPT. That's definitely a definition which should be in the glossary. A language model is just a model which can produce natural sounding text. You get that model, you train it on that data set, then you evaluate that model, make sure that it satisfies your operating points, make sure that it's accurate enough, make sure that nobody's going to be mad that this thing doesn't work. Then you can deploy it, typically by putting it into an API, so that your users can send requests when they use your app or when they write some code. They can send those requests to your API. It processes it by putting the data which they sent in their request through the model, and then returns it in a response, returns a prediction in a response. After that, you want to monitor things, make sure everything is going as it should be, make sure there's no downtime, make sure everything is still as accurate as it was when it started, which can be a problem if you're working with data which changes over time, like fashion trends or anything financial or impacted by trends in the world. And then finally, you need to now maintain the system if you build it yourself, right? It's not just a process of build it and put it out there. Like you need to, as with most software, maintain it. But I won't go into it here, but there's a bunch of very specific distinctions between traditional software development, deployment, maintenance, monitoring, and AI systems. And that's all another branch of what you call ML ops, ML operations. Not the point of this video, so I'll go into that at a different time. So if you don't want to build it all yourself, maybe you want to use a pre-trained model, then you're not going to have the get data and the train model steps. Instead, you're just going to have this one step at the beginning where you get the pre-trained model. You find a source online, typically on a website called Hugging Face. You can download the model from there, and then you go through the same process. You need to evaluate it, make sure that it hits your operating points. Then you can deploy it, then you need to monitor it, and then you need to maintain it again, because you will also need to host this one yourself. You'll need to run the computer which runs the AI system. But if you're not up for that either, it gets even easier, because nowadays there are so many third-party AI solutions out there that in a lot of cases, but certainly not all cases, you can just go. You can just go with it. So if you, for example, if you want to leverage AI to help your marketing team, then you can use third-party tools to understand your ad performance, create new visual ads, write copy, all kind of stuff. There are lots of solutions out there which, much like you probably have a bunch of other tabs open right now, you can just go on the application and play around with that stuff and leverage the AI in-app, in browser. So that's the usual process. I'm going to go more deeply into that in another video. If you have any questions about it or want to talk to me about it, you can just reach out to me. So how to determine what's hype and what's real? I think this is an important skill for you to have, because there's a lot of fear-mongering about AI. So now that you know what's under the hood, you know the kind of pieces that stack together to make these AI systems. You've got these models, which are just mathematical equations. We typically use neural networks, and lots of the powerful systems these days are based on transformers. We put that into an API, which our users can send requests to receive responses, and that's kind of the AI system. there. So we should be able to look at those components and understand, okay, what's hype and what's real. So let's use that knowledge to distinguish between those things. So here's a few points on the hype. AI will take all of our jobs. It really doesn't seem to be doing that. And it's been the same for the whole history of time, that as we develop new technologies, they take away our jobs, whether it was automation or outsourcing, all these kind of things. People were worried about them at the start. And the reality is that it really just doesn't seem to happen. As we produce these kind of systems, they make everybody more productive. Productivity drives down the costs. The cost increases spending power, and that means that people will have higher demand for things, which means there's more work available because we have higher demand to fulfill. And it doesn't look like AI is going to take all of the jobs really ever. I don't think it's gonna happen. I'll get more into details of that later. AI is conscious. That's another hype myth. It's not. It's really not. AI doesn't have its own goals or its own wants. It's not a living thing. It's just a computer program. In fact, as you know now, it's just a mathematical equation, right? You take some inputs and you process them by computing some math, and at the end of that, you arrive at some output prediction. When you understand that, you can see like these systems, they're not conscious and they're not having their own goals and going after them. So the types of systems that we have today, they really don't do that. Now, there are some, there is more and more work on building autonomous agents, AI systems which kind of use those mathematical functions to develop their goals and execute on them. But really, it's much just the same as any other code. If you code something to perform a series of steps, and one of those steps is to write a next goal and perform that step, it's really just the same thing as these AI systems that we have right now. It's nothing special. So AI really is just this function running, and much like any other software runs step by step, instruction by instruction, that's how AI software runs as well. And what's important to notice is that much like any software which runs out there on the world, is like it's owned by someone. Someone wrote it, someone owns it, someone has access to change it and edit it, and really like we control and oversee it. And everything which is happening, even using OpenAI's API, for example, like they can see all of that, they can shut that down, and this AI is not kind of scheming internally of how to subvert that. Another myth is that AI means robots. It doesn't. So AI doesn't imply any physical embodiment of some agent. It is, most of the time, it's just some code running. That's it. Another myth and a bit of hype is that AI is only accessible to the elite. I don't think that's true at all, really. It's in the hands of everybody. It's become extremely accessible and even free in most cases. You can use ChatGPT for free. You can use a lot of the image generators for free. You can use all kind of AI for free. And part of the reason for this is because if you're someone who develops AI, your incentive is to give it to as many people as possible because that's the largest possible market. So over time, these things only become more and more accessible. And that point relates to, I think, the crippling, the hype about this is going to cause crippling inequality. Really, what's happening is that AI is becoming really, really accessible, and it means that anybody who has an internet connection, which hopefully will be the whole world at some point soon, is able to use these AI systems for free. And that means they have the same power, the same tools, the same access to those tools as anybody. The only systems which are kind of really locked away and seem like they will stay locked away are the proprietary tools which are for specific internal use cases. All of Google's internal tools, there's probably a lot of AI that helps them, but it's really helpful in that specific situation for them. And so it's not like that's the kind of stuff which is gonna it's not like that's the kind of stuff which people all over the world need and should have access to achieve whatever they want. I think people have access to that stuff now. So anyway, what's real? What's real is that AI will change the nature of a lot of jobs. A lot of jobs are shifting in their priorities of what you actually have to do on the day-to-day basis, because a lot of those things can now be done or assisted by AI. I think here programming is my favorite example. As a software developer, you used to have to spend a lot of time thinking about, okay, what's the step-by-step algorithm for how I compute this thing? Nowadays, AI can write that code for you. And your job now shifts to being much more focused on, right, what's the business logic that I need to implement behind this? Another thing that's real is that AI makes it easier for bad people to do bad things. It does. But it also makes it easier for good people to do good things. And my hope is that we vastly outnumber and outperform anybody who has malicious intentions. And we can use these tools as a great defense against any kind of harmful activity. Another thing that's real is AI can be useful to almost anyone. I really believe that. It's not just for AI developers. It's not just for business leaders, because everybody's producing some kind of content, or maybe a lot of people are writing stuff. Everybody needs somebody to brainstorm with, which is a really great use case for these new AI systems. A lot of creative applications for AI. So really, I think I would challenge anybody to point out somebody to me, please. In fact, this would be great. Point out a job to me, DM me, or comment on a post, and try and come up with a job which I can't explain how AI could be helpful for that job. Another thing that's real is that AI can exacerbate existing problems. So, maybe it's bias or kind of problems which exist in the algorithms which really run our lives all the time right now. Maybe it's just bias preference for the kind of content you consume, which gets recommended to you, that kind of thing. AI can make that stuff worse. And that's an area where there's a lot of development going on and a lot of opportunity to build companies to kind of solve that problem. But as I said, it can also help tackle these issues. And it's a great tool to do that because it has a lot of general understanding, which is useful for a lot of real world problems, which involve humans, which do all kind of things generally over the place. 4 ways that every business should use AI. So some applications, these ones here, they're just so broadly applicable that they're worth highlighting to everybody, I think. Number 1 is an internal Q&A system. If you work at a company, it's likely that there are lots of different people across the company or lots of different manuals which contain the knowledge which you need. And a lot of people's time is spent finding that person, asking the question, clarifying details. And what's suddenly become possible recently is the ability to take all that internal knowledge from Slack, for example, where you're communicating with your peers in the workplace, and take all of those PDF files or Google Drive docs which contain your operating principles or the sales scripts, these kind of things, and show them to a language model which can then give you responses to questions, much like ChatGPT. So building your own kind of internal ChatGPT is a great use case, and it can save a lot of people a lot of time and make it really quick for them to get the information that they need. Basically, like a partner in your company, which you can ask a question, and maybe not all the time, but hopefully more and more of the time, it's got the solution and it gets it to you quickly. I think I've worked with a few companies who've implemented something like that, and it's been really useful. It's so easy to do that it's just worth doing. The second thing is external customer support. The bigger you get, of course, you begin to have questions and complaints and just things that customers want to talk about. And so companies always seem to develop these customer support teams. Now, that's a burden, and it's often quite it's quite tough for people in that role who are consistently answering the same questions over and over again. And so similar to the internal Q&A system, it's really easy these days. There are a few tools which I could outline for you to do it if you need any help for creating these customer support bots. And again, maybe they can't tackle every problem, but they can be a first line of defense that can make your customer support team at least 10% more productive, right? Probably much more. A third thing, which is a great opportunity for every business to use AI, is to draft written work, of course. Now, AI systems suddenly became very capable of writing, and we're all doing a lot of writing all the time, whether it's writing blog posts for marketing, whether it's formatting our rough notes from the meeting, whether it's writing a report about this quarter, or whether it's responding to emails. I find that these AI systems can be extremely useful in at least getting a first draft in 10 seconds, just like that, without having to wait for, without having to start from blank slate, which is often my problem, and I've seen be a lot of other people's problems in industry. So drafting written work is a real application because if you look at a lot of jobs, a lot of it involves written work, even if it's just writing that quarterly report at the end of every quarter. So in the fourth example here, I've already talked about, but programming. If you're a developer, you are crazy if you're not using an AI coding assistant. It's made me, I think, at least 50% more productive. Like I said before, what it does is it shifts your priorities as a software developer from having to think about the step-by-step algorithm. You don't have to do that anymore because the AI system can come up with that almost instantly. It can write the code. Your job then becomes being the manager, basically, reviewing the code, making sure that it captures all the business logic which you need it to. So the nature of the job shifts, and you can delegate a lot of what took time previously to these AI systems. And some of those can be some of the highest leverage applications in companies. But usually, most important applications of AI are actually company specific. I decided I'm not going to go into this thing here, but I run a process with companies which I call AI opportunity audit. And I'll do another video later explaining how that works. If you're interested in talking about that, I think it could be useful, just send me a message. But there's a series of steps which I usually go through to identify the opportunities and prioritize them for how companies can use it. So 3 steps to prepare for the future. My top advice, if you want to survive the AI revolution and adopt this new technology and be one of the winners from it. This is really important to understand. You will not be replaced by AI. You will be replaced by somebody who uses AI. AI is eating up a bigger and bigger percentage of our jobs, but there's always that small percentage, it seems, which is left over for us to connect the outputs of different AI responses together, or to curate what's tasteful, what makes sense in this case, what's in line with our brand. There's always some human element to it seems, and that becomes higher and higher level as these AI systems get more capable. So relates to my second point here, which is you have to think like this. I am a manager and I manage the AI systems. Essentially, these AI systems are going to be more and more capable to the point where they can do the work. When that happens, it basically means that you need to treat these AI systems as if they were your intern. And what do I mean by that? I mean, delegate the work. Can you explain it clearly? It's going to be a key skill. Can you tell the AI system exactly what you want? Secondly, reviewing the work and making sure it's up to quality, like you would with anybody that you manage. So I think that's important. You have to think of yourself as a manager. You manage the AI systems. And the third and final thing, which I think is important, is just to acknowledge that the landscape here is changing really quickly. Things are shifting beneath our feet. The technology is changing. The applications of the technology are changing. Consumer expectations are changing. And so I think it's extremely important to invest in staying relevant. I highlight this because I've worked with some companies recently that are struggling with an issue. They don't realize there's already a solution out there. So it's important to make sure you not only understand the jargon, understand the background of this technology, but you also invest in making sure that you can use it. So hopefully that's been useful. Just to recap, this is everything we've gone through today. I've tried to make it short, so it's probably been a bit of a blast. I'll do more detailed content on these different sections later. If you're interested, let me know. So we've gone through what actually is AI. We've gone through the essential AI glossary. How does it work under the hood? How can you differentiate between what's hype and what's real? Hopefully you understand some of those differences now. 4 common use cases of AI in business that I think everybody should be using because you probably have those roles. And then 3 steps to prepare for the future.